Okay, I want to add another shape to what we're dealing with, and that is circles. So let's review a little bit. Perimeter, remember the perimeter of a figure is going around the outside of the figure, going all the way around the outside of it. You're going to use it if you're creating a frame around a picture, if you're putting border on a quilt, if you're building a fence, you know, anything where you're doing around the outside of it, okay? Could be a triangle, whatever, but it's around the outside. And you can find it simply by adding all the sides together. The area of a figure is what's inside the figure, okay? You're going to use it if you're doing, say, carpet or paint or tile, because you're covering the whole surface with the carpet or the paint or whatever. You're covering everything on inside. For area, you use formulas. And they'll give you a formula sheet on the test. It's on D2L under the tab formula sheet, so you can take a look at it. But you don't have to memorize these. This will be given to you. You're just going to be able to plug it in. So it's good to look at the formula sheet in advance to kind of understand how it works. You're dealing with two-dimensional figures, length and width, generally, until we get to circles. But it's flat. The name of the game is it's flat. Even if it was circle, even if this piece of paper were cut as a circle, it would still be flat, right? And you're always going to give your answer in square units. And we looked at that in the video a minute ago on perimeter and area, so you can look back at that if you need to understand that better, why that's the case. But it may be written with the abbreviation SQ, so like square inches, or maybe look at this millimeters squared, square mile. Okay, so if you get a problem and they say how many square feet of sod will they need, if it says square units, they're asking to find area. The third way to measure a figure is volume. And volume is going to ask what's contained inside a figure. It's going to be things like liquid. Liquid will always be measured in volume. If you have a hole that they've dug out, okay, or if you have a pile that comes up, again, formula. And they'll give you the formula sheets for this. Volume is going to measure three-dimensional figures. Generally, it's like you're talking length, width, and either height or depth. So that's what I'm saying. If it's a hole, obviously, then it goes down. It's the depth. If it's a pile, then it comes up and it's height. But it's got length, it's got width, and it's got height or depth to it. Volume is always measured in cubic units. They might write the word out, cubic inch, or they might abbreviate CU like cubic centimeters, or look here, it says feet cubed. So that's really important too. I've seen a question before where they're asking some different measurements things, and the key to the whole answer is cubic, because they're asking you about a flat figure. Well, a flat figure is not going to be given in cubic units. So be mindful of all these different tips. Now, when we move on to a circle, some things stay similar, and then there's a couple little variations. The perimeter, so to speak, going around the outside of a circle, is actually called circumference. So you'll have to memorize that. They mean the exact same thing. You're going around the outside of a figure. Now there is, though, a formula for circumference, because we can't literally add our way around a circle, can we? The area is still going to be inside it, and it's still going to be square units. Volume is still going to be what contains in it, a circular figure, and it'll be cubic units. So those things stay the same, and you'll be given the formulas. So here's the thing. With circumference, I'm going to tell you what the formula for circumference is. Again, it will be on the formula sheet. The circumference is 2 times pi times the radius. All right, we need to define a few things, don't we then? This symbol right here is called pi. It's the Greek symbol. That's what it looks like. And it stands for pi, Pi. What we will typically use for it is approximately. That's why I drew this squiggle. That was not a mistake. It is approximately 3.14. It actually goes on forever. If you hit the pi button on your calculator, you'll see that. But we use 3.14, okay? Fun fact, there is a National Pi Day. When do you think it is? If you said March 14th, you're correct. January, February, March is the third month the 14th day. There really is a National Pie Day. My last meal out pre-quarantine was on Pie Day, when I got to go back out after the quarantine. And I was thinking, I wonder how long it's been. It's been probably 8 weeks since I've been in a restaurant. I know exactly when it was, because my daughter and I went out on Pie Day to BJ's. They had their mini pizzas for $3.14 to celebrate Pie Day. So that's what we math geeks do. So hopefully that'll lock it in your mind. Pi is the measurement 3.14 is what we use. And it's because if I was trying to measure this circle, you know, with a ruler and tilt it all the way around, I'm not going to be able to get a terribly accurate response or measurement. But pi takes that into account, and it's a brilliant way of understanding the measurement of a circle. So let's go piece by piece then, because I really encourage you to do this on your formulas. Just plug in. So when I see pi, I'm going to use 3.14. There is a pi button on your calculator, but that's not what the test is going to ask you. They'll remind you to use this. So where 2 pieces are in. Radius, the R. What does radius mean? Well, the radius is represented by the little r, okay? Radius is halfway, really want to emphasize that, halfway across the circle. Goes from the center to the edge. In other words, if I had this circle right here and I go like that, from the center to the edge, that is the radius. That's r. Let me show you though so we understand this. Right there from the center to the edge, that is also a radius. Radii is the plural, so we have an infinite number of radii to our circle. And every one of them has the exact same measurement, because that's really the definition of a circle. A circle is a group of points that are equidistant from the center, meaning it's exact same distance from here to here to here to here to here to here, all these places. Those are all radii, and they're all the same distance. Okay? So that's our radius. That's what it is, from the center to the edge, halfway across the circle. Well, the other way to measure on a circle is the diameter, and that'll be listed usually with a lowercase d, okay, the diameter. Here's the thing, the diameter is all the way across a circle, through the center, okay? So in other words, this would be the diameter, all the way across. And again, I can draw an infinite number of different diameters. I can go all over the place with my diameters, just making teeny tiny changes all the way around my circle, like spokes on a wheel. And they're all, every diameter is gonna have the exact same value. So suppose I told you on this, I said the diameter of this circle, the radius of this circle is 3 inches. I want you to think for a second. If the radius is 3 inches, what is the measure of the diameter? If you said 6, you are correct. Because look, that's actually another radius, isn't it? So that's also 3. So all the way across the circle would be 6. Does that make sense? I hope so. Okay, so drawing from here, I want you to realize the radius is halfway across. The diameter is all the way across. Sometimes this helps people. If it helps you, great. If it doesn't, ignore it. I'm actually going to cover it up again in a minute, because for some people they love it, but some it's distracting. So in looking at this, do you notice that literally the diameter is 2 times the radius? The diameter is 2 times the radius. This is not another formula you have to memorize. That's why I hesitate to show it, because people are like, oh no, I've got to learn that. No, if you understand the concept, you can come up with it, right? The diameter is going to be 2 times the radius. I told you the radius was 3, so we go, I know then, the diameter is 6. The radius, therefore, is half the diameter. If I told you that the diameter of this circle is 8, and I said, what's the radius? It'd be 4, because it would be half that. So let's leave that here for a second. Let me give you a few questions to ask you. If I say that the radius of a circle is 6, what is the diameter? 12. If I said the radius of a circle is 9, what is the diameter of that circle? 18. If I say the radius of a circle is 5, what's the diameter? Excellent, it's 10. But let's go the other way now. Suppose I say, let's erase these. So you see that you have to double it, the radius. But suppose I tell you that the diameter of a circle is 12, and I ask you what the radius is. Think about it. It's 6. Because the radius is half the diameter. The diameter is all the way across, the radius is half that. So if the diameter is 12, the radius is 6. Suppose I say the radius is, the diameter is 26. What's the radius? You can do it on your calculator. I need a half that, it's 13. Just so you recognize this, suppose I told you the diameter is 7. If I use an odd number, what is the radius? Well, it's half of 7. You can do it on your calculator, but it's 3.5 or 3.5. So we don't have to be scared if it doesn't work out as an even number or as a whole number, but just realize it'll be either a fraction or decimal, however they write the problem. Okay, so you're kind of following that pattern. I'm going to cover that up so it's not distracting to you, but I hope you see that, because here's the reason that that is so important. They're going to give you on the test, I'll bet there'll be at least one question on the test where they're going to give you the diameter for whatever, whether they're measuring just a circle or it's a ball or a cylinder, something like that. They're going to give you something circular and they're going to give you the diameter, and you have to realize, it's the radius I need though. So you've got to remember to half it. So that other piece then, the R. So let's say on this circle right here, let's suppose I gave you this, and I told you the diameter is 12. Well, I need the radius, right? So the radius is what? I hope you said 6, because that would be right. So then this is a calculator problem right here from here on. Let me grab my calculator. So I would solve this. I would do 2 times 3 point, there's my decimal point, 14, times 6. So the circumference of this circle is 37.68. Try that on your calculator right now while you're looking at it. 37.68. Now, what you see a lot of times on the test is they'll say, what is the circumference of the circle rounded to the nearest tenth? So let's round this to the nearest tenth. Let's think it through a little bit. Tenths, hundredths. So I'm rounding it to this single place here. What happens with that 8? It makes my 7 round up, right? So if they ask that, round to the nearest tenth, my answer would be 37.7, because that 6 would round up. So that would be the circumference of that circle. Kind of following that? Okay, let's do it with a different measurement. Hope you've seen it all. Okay, let's suppose my measurement, my circle had let's say that this diameter is 6. Well, let's find the circumference. 2 times pi, good news, pi does not change, so I know that one, times the radius. What is the radius of this circle? If the diameter is 6, the radius is 3. Okay, so again, use my calculator. 2 times 3.14 times 3, 18.84. So my circumference would be 18.84 inches, or whatever these are, centimeters, okay? And if they wanted it rounded to the nearest tenth, what would be this to the nearest tenth? This is the tenths place, that's the hundredths. To the nearest tenth, it would be 18.8, because the 4 would drop. Okay? So that's how you do circumference. So if I have, you know, Susie goes out and walks around a circular track that has a circumference of, let's make it ridiculously big, just so we stay with things that we know. Let's say 6 miles. How far does Susie walk? Well, if the, I'm sorry, I said circumference, with a diameter of 6 miles, if it's a massive circle, like around a lake or something like that. Well, if the diameter is 6, then the radius is 3, so we figured out like this. So Susie's going to walk 18.8 miles because she just walks around the outside of it. Okay, well, what happens if we're dealing with the inside then? This is the formula for circumference, which is the outside. Or if you're building a frame around something circular, or you're putting a border around a circular mirror or something like that with a circle. That's the circumference. But what if we want to measure the inside? Suppose we want to put dirt all inside there. We want to know how much area it's going to cover. Use the word area. Sometimes, oh, that's a good thing. I want to put on here too. Sometimes also on area, they'll use the word space, and not like outer space, but like how much space will this take up? Okay, if they ask that question, they mean area. So let's suppose I'm using this exact same circle, and I'm doing the area. So I'm doing the inside, everything in it. Okay, again, you'll be given the formula, but the area of a circle is pi times the radius squared. Pi r squared. Do you remember this when you first learned this? And they say pi r square, you go, no, they're not, they're round, right? Bad joke, right? Pi times the radius squared. Okay, so this has got a couple of little extra pieces here. Pi is 3.14. My radius, my diameter is 6, and my radius is 3. So I'm going to do 3 squared. Now you got to remember what exponents are. Okay, and you can look at that, go back and look at the exponents tab. It will also be on your calculator. There's actually, you see x squared right there, x squared. So if I wanted to do 3 squared, I could do 3 squared. This is awesome because you look at it and you see it actually writes the exponent in there. So you can look at it and go, okay, I put what I wanted. 3 squared is 9, okay? I hope you know that anyway, that 3 squared literally means 3 multiply. They're always multiplication for exponents 2 times. So it's 3 times 3, which is 9. So let's just walk our way down our formula. Again, we want to stay neat and just walk our way down, okay? So 3.14 times 9, 3.14 times 9, 28.26. 28.26. Let's say I make this centimeters. This is area, so it is centimeters squared. If they asked you to round this to the nearest tenth, what would it be? Tenths, hundredths, so it would be 28.3, because that 6 is going to make the 2 round up. So that's how you find the area of a circle. Okay, I hope you're following through that pretty well. You're going to just walk your way down through it. Be sure you understand the square, and you can certainly use the button. So let me show you then the other measurement. I'm going to erase that. The third way to measure anything is volume. And suppose we're dealing with something circular. Okay, this is a cylinder. All right, I could make it come back like that so you can kind of see the back of it. But so this would be a cylinder. This is not a great example, but like a bottled water, because this is, notice how this comes in at the top. We're not doing that. Imagine you snipped it off right here where it's all the exact same thing. Okay, so that would be a cylinder. A question they seem to like on the test sometimes is a silo. If you ever driven through a smaller town, or even like Yukon has silos on Main Street, a silo, a grain silo, it's the really tall, really tall structure outside. It's circular, but then it's really high, and that's where they store grain. Okay, you don't need to know the grain thing and everything, but when they say silo, we're talking about a cylinder. All right. But if they may just flat out say cylinder, a piece of pipe would be a cylinder, things like that. So here's the thing with this. When I'm looking at volume, I'll be given the formula. The volume of a prism, which would be a box, like I used this the other day. So how much could this contain? The volume of a prism or cylinder is found the same way. And let me show you that formula. The volume is the area of the base times the height. Okay? The area of the base times the height. Well, if this were a box like this, what shape is the area of the base? It's a rectangle. And remember, I've shown you before, if I did it this way, same thing. If I did it this way, same thing. Okay? Because it's 3 dimensions. So the area of the base is going to be length times width, or base times height, however you want to look at it. And then I multiply, well, it'd actually be this part if I'm doing it this way. And then I multiply it by the height. So that all makes sense. On this, though, what is the shape of my base? On a cylinder, what's the shape of my base? It's a circle. So again, handy dandy formula sheet. The area of the base. What is the area of a circle? We just looked at that. The area of the circle is pi times the radius squared times the height, because we're doing the volume, right? So all I did was I plugged in pi r squared for the area of the base times the height. So then we've just got to work with our numbers, whatever our numbers are. Pi, we know, always 3.14. Suppose I told you this one. I gave you that measurement. And that, this is my drawing. What's the radius? I gave it to you. It's 4. I didn't give you diameter, I gave you radius. So 4 squared times the height. What is the height? 10. Okay. So let's keep going. Let's work our way down better, solving it piece by piece. 4 squared. Remember what square means. It means the number times itself. 4 squared is 4 times 4. What is 4 times 4? 16. All right? Let me just remind you a little of this, because I want you to keep these in mind. You're going to have the calculator, but what would be 5 squared? 5 squared is 5 times 5, 25. What is 6 squared? 6 times 6, 36. What is 8 squared? 8 times 8, 64. It's important to understand the exponents, but on the test, certainly, you could use your calculator. So if I get to this 4 squared, I do 4 squared. It shows it up as I see the exponent up there, floating up there, is 16. So I can always confirm it. So that's 16, and then I still have the 10, right? All right, so my last step then is going to be to put all that in my calculator. So I'm going to do 3.14 times 16 times 10. Final measurement, what I came up with was 502.4. And let's say this is feet. So it is going to be cubic feet because I'm doing volume, so it's always in cubic. It's always, because notice it's three-dimensional, right? It has kind of, so to speak, you know, it kind of has a width to it about it, to those dimensions of the flatness of the circle base, and then it has the height. So the answer would be 502.4 cubic feet. That would be the area, or I'm sorry, the volume for this. So on your sheet, it's going to give you some different things, all the formulas. Let me show you one other term that deals with a circle that you need to be sure you know. I'm going to go ahead and erase this. Let me completely take this off even. This is a really important word. It's going to show up. It may show up. Sphere. A sphere, okay? Do you know what shape a sphere is? If they were to give you something that you'll need, this, because that's what it's going to show up on the formula sheet. It's going to say sphere, the volume of a sphere. It's like, what's a sphere? It's a ball, okay? It's a three-dimensional circle, so to speak. I'm going to try to draw that. I won't draw the third dimension, let's just say. But it's, if I had this, it's a ball. We've got round, but then it's got that third dimension. If I had a globe, you know, that would be a good example of one. You think about it when we measure the Earth, we talk about the northern hemisphere and the southern hemisphere, so the half spheres, right? So a sphere is circular. The volume formula, don't panic, is 4/3 times pi times the radius cubed. Okay, great news. So your calculator would do all that. So if I had this situation where they wanted the volume of a sphere, this is what I'm going to need. So let's play like this. Suppose this is my sphere, and again, remember, it's three-dimensional. I did not draw three-dimensional. This is a ball, okay? And they gave me this drawing, or they just told me a sphere with diameter 10. What is the volume? Well, I hope you're not going to get fooled by that. If the diameter is 10, the radius is 5. Remember, it's half. So 4/3 times pi, hey, we know pi, 3.14, times the radius, which is 5, cubed. This literally means, remember, exponents are always multiplying, so it's going to be 5 times 5 times 5, because there's 5 3 times, right? Calculator does that. You can use a little bit of a different button on this. You're going to use this little, that up arrow right there. So watch, I'm going to do 5, then I'm going to hit that up arrow, and it puts the cursor up at the top, so I know I'm doing an exponent, so I know I'm doing it correctly. I get the 3 there. I'm going to scoot over just so I can look at it. 5 cubed, that's exactly what I want. 125, which I could have done, right? Because 5 times 5 is 25, times 5 is 125. So let's walk our way down neatly. My point about being neat is just so you don't lose something. You don't get points for neatness, but it does help in math to not mess things up. Okay, so that's what I've got. So now let's plug all this into my calculator. 4/3. I've actually done the fraction, numerator, denominator, 4/3 times 3.14 times 125, and it equals, let me write this down here. 523 point, and you'd see it goes 3, 3, 3, and so on. So let's suppose I'm rounding to the nearest tenths, hundredths. So it'd be that right there. And let's make these centimeters. So it would be cubic centimeters. So that's how you're going to do the volume of a sphere. So if they ask that, just take it piece by piece and walk your way down through it. Remember to find the radius. That's going to be key. If they give you diameter, find the radius and walk your way down. But a sphere is essentially a ball, okay? A ball, a globe, things like that. So if they give you those kind of problems, I want you to know, oh, I need the sphere formula to work with. Let's back up just for a second and use this exact figure, but I'm going to pretend it's two-dimensional right now. It's just this circle, and let's do one final solve on this. So circumference, I would look on my sheet, and I'd say it's 2 times pi times the radius. So 2 times 3.14, I would look on this circle, and I'd say, hey, it has a radius of 5. 2 times 3.14 times 5, I get my calculator out, and I would do 2 times 3.14 times 5, 31.4. So it is the circumference of this is 31.4 centimeters. So if I'm walking around this, or if I'm building a fence around something circular, or I'm putting a border around it, any of those kinds of things, I would need 31.4 centimeters of material for that. If I wanted the area of this circle, it's pi times the radius squared, 3.14, radius is 5, don't be tricked into thinking it's 10, 5 squared, 3.14, I could use my calculator for 5 squared, but it's 5 times 5, which is 25. 3.14 times 25 is 78.5 square centimeters. So if I wanted to know how much space that circle would take up, it would take up 78.5 square centimeters. So really learn these different clue words, and then learn how to walk your way down through the formula.